Welcome to lesson 8 overview. So this is now in inferential statistics. So we are going to be using probability models to, in this case, make predictions. We're going to create confidence intervals. You might think of political polling where they say this person has, is polling at 50% approval rate plus or minus 8%. That's an example of a confidence interval. Right, so we have an estimate, point estimate. We're estimating the parameter, the true proportion of the population or the true average of the population. And then we have some margin of error. That margin of error comes from the assumed distribution, and that's where we relate to the central limit theorem. So I think that sometimes looking at examples of confidence intervals, it's very formula heavy. And then going back to kind of see where those pieces come from can be helpful. So 8.1 is going to go over kind of the theory. But if you skip ahead to some of the examples, if it's confusing at the beginning and you skip ahead to some examples, hopefully you won't get overwhelmed by the confidence intervals themselves. Right. So we make the connection to the central limit theorem, which gives us the width so that we can have a certain confidence level that we are 95% sure that this interval contains the true parameter, or 90% or 99%, right? And that'll depend on our sample size and our confidence level that gives us that margin of error. So there's, we will need the t distribution. So this is a new distribution that's a little bit wider, doesn't have quite as much, or has more probability in the tails. So it kind of gives us a little bit more leeway. We say we're a little bit wider in our confidence intervals because we are going to be estimating the standard deviation instead of using our sample statistic, instead of being given the population one. So read about the t distribution. Most confidence intervals will be using a t-score, not a z-score. So pay attention. This t-score calculator is so you can figure out what t-score you need for a given confidence level. So the degrees of freedom, this is one less than your sample size. Enter your appropriate confidence level, so 95%. You'll hit calculate, and then we'll always take that two-sided t-score. That's going to be how you can find the t-score. So on your homework, when you're asked to give your t-score, make sure that you label the degrees of freedom and your confidence level, and then give that corresponding t-value. So I know where it came from in case the value is wrong. Was your degrees of freedom wrong? Was your confidence level wrong, for example? So you got online homework, and then lesson 3 is about proportions. What if we want to do a confidence interval not on sample means, but on sample proportions? So we can also do that. Nice thing about sample proportions is we are using a z distribution. Proportions tend to be binomial, and as we've seen, binomial can be approximated with a normal distribution, and normal distributions correspond to z-scores. So there's an example doing a confidence interval on a calculator and by hand, and then an example finding appropriate sample size for proportions. Right down below, here are some examples. If you have raw data, if you have statistics or proportions, how to find these confidence intervals on your calculator. Here are some online resources that, again, will give you the confidence interval if you enter in the values. But on your turn-in homework, be sure that you show all of the pieces. These can give you the end values of your interval itself, but to show your work and to get full credit on your turn-in homework, you will need to show all of the pieces of the formula so I can make sure that you understand where the formula comes from. All right, and that is all. Enjoy confidence intervals.